Hello, this is Wylock number 19. Well, let's just get started. Now we're just going to be reviewing factoring out polynomials. So, simple enough, we just factor out the common factor, which is just 2. So you get 2x squared plus x. But wait a minute, there's also an x that you can factor out as well, since they share a common factor. So what you can do is you can factor out that x. And you get 2x plus 1. And that would be your answer. Moving on. For this, we have 3x squared plus 6x plus 9. We know that we can't factor out the x since there is an x absent over here. So what we can do is we know that 3, 6, 9, we can actually factor out a 3. So if you do, you get x squared plus 2x plus 3. And that would be your answer. Now, let's try multiplying polynomials again. So, simple enough, we're just multiplying each term by this x. So you get 2x cubed minus 3x squared plus 9x. And that would be your answer. For this one, you would distribute y into each term. So negative y cubed minus 2y to the 5th minus y squared. And that would be your answer for that problem. Moving on, let's try 3x to the 7th times x to the 4th minus 4x. Well, 3x to the 7th times x to the 4th is just 3x to the 11th. Since when we multiply these two together, you can just add the exponents when you're multiplying the same based exponents. So 7 plus 4 would just be 11. Now, if we multiply to the second term, we get negative 4x times 3x to the 7th, which is just negative 12, since 4 times 3 is 12. X times x to the 7th would just be x to the 8th. So you get negative 12 8th. 3x 11th times 3x to the 11th power minus 12x to the power of 8. And that would be your answer for number 5. Now let's try applying exponent properties involving quotients. So what this basically means is that when you divide exponents, you're basically just going to be subtracting. So you would get a to the 5. And the reason for this is if you actually wrote out all the 8s, 3, 4, 5, and that gave you 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 5 eighths. 8 times 8 times 8 times 8 times 8. Now, if you cross out every 8 that exists on the numerator and denominator, all you're left with is just 1, 2, 3, 4, 5 eighths left. Since that's 1 pair, that's 2 pairs, that's 3 pairs, that's 4 pairs, and that's 5 pairs. So all you're left with is 5 eighths, which is the number that we determined before. Let's try negative 3. Negative 3 to the 9th, negative 3 to the 3rd. Well, since it's an odd exponent, we know that even though if we multiply this out, the negative will still be there. So, if we do that, we can just leave this negative 3 alone. But we can reduce the exponent since they have the same base. So 9 minus 3 would be negative 3 to the 6th power. And that would be our answer for that problem. Well, that's it for today. I hope you have a Merry Christmas.